tap rules outlined in the National Electrical Code, specifically in Section 210.24, permit the use of 14-gauge wire taps from a 20-amp circuit, but only under specific conditions. The primary condition is that the tap conductors must be protected by a 15-amp overcurrent protective device. This means that the portion of the 14-gauge wire connected to the 20-amp circuit must be short, and then immediately be protected by a fuse or circuit breaker no larger than 15 amps. This is to protect the 14-gauge wire from being overloaded beyond its capacity, which is typically rated for 15 amps. One common way to achieve this protection is by using a 20-amp receptacle that incorporates a built-in 15-amp ground fault circuit interrupter, or GFCI, or arc fault circuit interrupter, or FSI tripping device. These specialized receptacles allow a 20-amp circuit to feed them, but they will trip internally at 15 amps, effectively protecting the 14-gauge tap. The purpose of the GFCI is to protect people from electrical shock hazards by detecting small imbalances in the current flowing through the circuit, which can indicate current leakage to ground. The FSI protects against fires caused by arc faults, which are dangerous electrical discharges that can occur due to damaged or deteriorated wiring. In these scenarios, listed 20-amp receptacles can also be used with a standard 15-amp GFCI or FSI circuit breaker installed in the electrical panel. This setup provides the necessary overcurrent protection at the source, ensuring that any fault in the 14-gauge tap wire will trip the breaker before it can cause damage. The code addresses various situations. One example is when a 20-amp receptacle is required to have 20-amp overcurrent protection. However, the idea that 14-gauge taps are never allowed on a 20-amp circuit is a misconception. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and proper functioning. Understanding these guidelines is crucial for electricians and anyone working with electrical systems. The NEC Table 210.24 summarizes the requirements for branch circuits, including the permissible ampacities of conductors, the types of overcurrent protection required, and the number of outlets allowed. A key aspect of working with electrical circuits is understanding the concept of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating, fire, or equipment damage. These devices interrupt the flow of current when it exceeds a predetermined level, safeguarding the wiring and connected devices. The ampacity of a conductor refers to the maximum amount of current, measured in amps, that the conductor can safely carry without exceeding its temperature rating. The ampacity of a wire is determined by factors such as its size, material, insulation type, and installation conditions. It is essential to select conductors with ampacities suitable for the intended load to prevent overheating and potential hazards. Now let's consider a practical example. Suppose you have a 20-amp circuit that you want to use to power several devices, including some that are connected using 14-gauge wire taps. According to NEC Section 210.24, you can use 14-gauge wire taps on a 20-amp circuit if the tap conductors are protected by a 15-amp overcurrent device. In this case, you could use a 20-amp receptacle with a built-in 15-amp GFCI or FSI tripping device. Alternatively, you could use a standard 20-amp receptacle with a 15-amp GFCI or FSI circuit breaker in the panel. In both cases, the 15-amp overcurrent device will protect the 14-gauge wire taps from being overloaded. Here are the key takeaways regarding 14-gauge wire taps on 20-amp circuits. Firstly, NEC Section 210.24 allows the use of 14-gauge wire taps on 20-amp circuits under specific conditions. Secondly, the tap conductors must be protected by a 15-amp overcurrent device. Thirdly, this protection can be achieved using a 20-amp receptacle with a built-in 15-amp GFCI or FSI tripping device. Fourthly, it can also be achieved using a standard 20-amp receptacle with a 15-amp GFCI or FSI circuit breaker in the panel. Finally, understanding these rules is essential for ensuring electrical safety and compliance with the NEC. Another important consideration is the type of devices that can be connected to a 20-amp circuit with 14-gauge wire taps. Generally, it is acceptable to connect devices that draw 15 amps or less to such a circuit. This includes items such as lamps, small appliances, and electronic devices. However, it is important to avoid connecting devices that draw more than 15 amps, as this could overload the 14-gauge wire taps and cause them to overheat. In addition to the overcurrent protection requirements, there are also other factors to consider when using 14-gauge wire taps on 20-amp circuits. These factors include the length of the tap conductors, the type of insulation used on the conductors, and the way the conductors are connected. The tap conductors should be as short as possible to minimize the risk of voltage drop and overheating. The insulation on the conductors should be rated for the voltage and temperature of the circuit. The conductors should be connected using approved methods such as wire connectors or solderless terminals. One of the most common mistakes people make when working with electrical circuits is to underestimate the importance of proper wiring techniques. Poor wiring can lead to a variety of problems, including overheating, voltage drop, and electrical shock. It is essential to follow all applicable codes and standards when wiring electrical circuits, and to use high-quality materials and tools. Another common mistake is to overload electrical circuits. Overloading a circuit can cause the circuit breaker to trip, and it can also damage the wiring and connected devices. It is important to calculate the total load on a circuit before connecting any devices, and to make sure that the load does not exceed the circuit's capacity. Here are some additional tips for working with electrical circuits. Always turn off the power to a circuit before working on it. Use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment such as gloves and safety glasses. Follow all applicable codes and standards. Use high-quality materials and tools. Get help from a qualified electrician if you are not comfortable working with electrical circuits. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring electrical safety and preventing fires and other hazards. There are many resources available to help people learn about electrical safety and the NEC. These resources include books, websites, training courses, and qualified electricians. By taking the time to educate yourself about electrical safety, you can help protect yourself and your family from electrical hazards. Electrical work can be dangerous, so it is important to take precautions. If you are not comfortable working with electrical circuits, get help from a qualified electrician. Here are some additional points to consider regarding 14-gauge wire taps on 20-amp circuits. Firstly, it is important to note that the use of 14-gauge wire taps on 20-amp circuits is not always the best solution. In some cases, it may be better to run a separate 15-amp circuit to power the devices that require 14-gauge wire. Secondly, the decision of whether or not to use 14-gauge wire taps on a 20-amp circuit should be made on a case-by-case basis, taking into account the specific circumstances of the installation. Thirdly, it is always a good idea to consult with a qualified electrician before making any changes to your electrical system. Fourthly, when using 14-gauge wire taps on a 20-amp circuit, it is important to ensure that the connections are made properly and that the wires are securely fastened. Fifthly, loose or corroded connections can cause overheating and increase the risk of electrical shock. Sixthly, it is also important to periodically inspect the wiring and connections to ensure that they are in good condition. Seventhly, if you notice any signs of damage or deterioration, such as frayed wires or cracked insulation, you should replace the wiring immediately. Eighthly, the NEC provides detailed guidelines for the installation of electrical wiring and equipment. Ninthly, these guidelines are intended to ensure the safety of people and property. Finally, it is important to follow these guidelines carefully when working with electrical circuits. The NEC is not a static document. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. There are many ways to stay up to date on the NEC. You can subscribe to an electrical industry newsletter, attend electrical trade shows, or take continuing education courses. You can also consult with a qualified electrician or electrical inspector. In conclusion, the use of 14-gauge wire taps on 20-amp circuits is permitted under certain conditions, as outlined in NEC section 210.24. The key requirement is that the tap conductors must be protected by a 15-amp overcurrent device. This protection can be achieved using a 20-amp receptacle with a built-in 15-amp GFCI or SI tripping device, or a standard 20-amp receptacle with a 15-amp GFCI or SI circuit breaker in the panel. Understanding these rules is essential for ensuring electrical safety and compliance with the NEC. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring.